Hey everyone, welcome to another Arduino lesson. I hope everybody's doing great. So we've talked a little bit about blinking LEDs, stuff like that, a lot about theory, how the board works, coding, and all that stuff is definitely need to know. But today we're going to talk about buttons and using buttons with the Arduino. And this is something that you're going to find yourself doing a lot of. So this is basic yet important. And as always, to avoid information overload and complicating things, we're going to start off simple and then progress from there. So I have here a little push button switch, the kind that you might use with Arduino, and I have a schematic representation of this switch. And one of the first things to notice about this is that we have 4 pins, 1, 2, 3, 4, and 2 of them are connected internally and another 2 are connected internally. And if we flip this guy over, indeed we can see there are 4 little pins. And when you're using this button, you got to be really careful that you hook it up right, because again, there are 2 and 2 pins that are connected internally. So theoretically, you could use this button to control 2 devices at once, but you may or may not want to do that. The question here that we're going to try to answer, or we are going to answer actually, is, okay, how do I know out of these 4 pins, looking at this thing, which ones are connected inside and which ones are not? And the answer to that is pretty simple. And what I'm going to do in order to stabilize this so it doesn't move around is I'm going to break out this little breadboard here, and I'm going to stick this button first in the breadboard across this gap, because all these points are connected, and this kind of breaks it so these are not connected all the way across the board. So I'm going to do that, and I'm going to grab my trusty ohm meter, and I'm going to put it on continuity. Now, you don't have to do this, because if you put it in the breadboard wrong, you're going to get a wrong reading. For example, if I were to stick the button here, since these points are all connected, and I put it in the wrong way, I would get a false reading. But I'm just doing this because I don't want the button to move around when I'm trying to take the reading. So I'm going to go ahead and do my reading here, and I'm going to take these 2 pins. And you hear that noise, that means these 2 pins are connected internally, and on the other side, same situation. And then over here we have these 2 pins that are not, unless of course I press the button, which I'm doing now, then I'm letting it go. So that is how we figure out which ones are connected and which ones are not, and how to properly wire a switch. So let's get rid of that. I'm going to bring in this circuit here. And here we see the Arduino Uno. We have a push button switch, an LED, and a couple of resistors. There's a 1K here to limit the current to the LED, and then here's a 10K resistor that serves a different purpose. We'll talk about that in a minute. But I'm going to go ahead and demonstrate the circuit. So first we know what it does, and I think you already probably have a pretty good idea of what it's supposed to do. And when I push the button, the LED comes on. When I let it goes off. And I want to kill this light for a minute so you can see a little bit better. Okay. So I'm pushing the button, LED comes on, and when I let the button go, it goes off. And there's a slight delay there, but for all intent, that's the way it works, and that's fine. So I want to look at the schematic, take a closer look at the schematic, and talk about how this is wired. And then we're going to get into the code and discuss the code for this, and maybe make some modifications too to make this circuit a little bit better. Well, I don't want to use the word better because it really depends on what you're doing with it. So we're going to go ahead and make some modifications to the code once we get into the code to change its behavior slightly. But first, we're going to jump over and take a look at the schematic and discuss really quick how it's wired. Okay, everybody, here is the schematic. Before we get into the code, I just want to quickly go over it. So here we can see we have our push button switch, and like I said, there are 2 points that are tied together here internally and here. So we're not using these other 2 pins. We're just using the one going to 5 volts, and then the other one is going to this 10K resistor here, which we're going to talk about in a second.
And I do want to note before we go any further that these 2 points here, they are not connected. Okay, just to make that clear, there is no connection here. So we have just an LED with a current limiting resistor. The cathode goes to ground, and then the resistor limits the current so we don't burn out the LED or actually burn out the Arduino, because these pins can only source so much current. And then here on pin 12, we have this 10K resistor. And when the switch is open, this pin 12 sees 0 volts. But when you push the switch and it closes, what happens is it sees the 5 volts applied. The 5 volts drops across this resistor, and the pin 12 sees 5 volts. So if you were just to imagine taking your voltmeter and then putting the positive lead here and then the negative lead at ground, if you were to do that and then close a switch, you would see 5 volts. So this resistor is here, so the pin sees the 5 volts when the button is pressed. So this pin 12, kind of controls pin 11, and you'll see in the code exactly how that works. But really, that's all there is to the schematic here. Not much else to it. So let's go and take a look at some code. So here we are in the Arduino IDE, and I've already have the code up that controls the circuit that we talked about and turns the LED on when the button is pressed and off when it's released. So let's go through this line by line so we know what all this stuff means. Up here, we just have a couple of integers we declare, and these are just pin numbers. So the button was connected to pin 12, we may remember, and the LED to pin 11. So that's all this is just the pin numbers here. Then we have button state, which is another variable, and we're going to go ahead and set that equal to 0. It's going to give us the push button status. So that's all before setup, and here we come into setup, and you see the pin mode function we talked about in an earlier tutorial. And really all we're going to do here is take the button pin, make it an input, and the lead pin, make it an output. And that's all there is to setup. Now, we fall into the loop, and we're looking at the button state again, and we're going to say, okay, we need to set the button state equal to whatever digital read, which is the other function we talked about too in the earlier tutorial. Digital read is going to read the status of the button pin, and it's going to be either true or false, 1 or 0. So button state is either going to be, well, a 1 or a 0. Now we set it equal to 0 already, so it's going to be off by default. Then we have an if statement. Now, you might remember hearing about the if statements in the earlier lesson. I think it was lesson 12 on control structures. So I'm not going to go into great detail here because I did talk about if and if-else statements back in lesson 12. If you want to review it, go back to lesson 12. But we need this if statement to decide whether or not the LED is on or off. So we're just going to fall right in here, and if button state equals high. And notice I have a double equal. We're not using the assignment operator, we're using the double equal comparison operator. So if button state is high, we're going to use a digital write function again, and we're going to write a high to the LED pin, which was pin 11, and that's going to turn the LED on. Else, if button state is not high, then we're going to use digital write and write a low. And here I have a delay that is actually, I don't know why it's commented out, but I did want to insert a small delay too. So that way the LED has time to react. So that's the code in a nutshell. Not too complicated. But what if we want to press the button once and then let it go and have the LED stay on? And then if we want to turn it off, we come back later, press it once again, and it goes off. See, with this, you have to hold the button if you want the LED on, and then as soon as you let it go, it goes off. And there may be some instances where this kind of code and this kind of setup works, but it is possible to change it so that way we can turn the LED on and keep it on once we let go of the button. And we don't have to modify the circuit at all. We can leave the circuit alone, same schematic, same circuit. So let's think about how we can do that. So what we want is a variable that the loop function can examine and check to see if the LED should be on or off. Then when we're in a loop, we need to check the push button. Now if it's pressed, we got to check the LED state. If that state's 0, we got to change it to 1. And if it's 1, we got to change it to 0. And this is called toggling, by the way. When you toggle something on, off, it's just toggling is another word for it. And then we also want a little delay, so we're going to use the delay function again so we can get our finger off of the button. It just gives us time to let it go because it's going to run through the loop pretty fast, remember, so we need time to react and let go of the button before it runs through the loop a second time. So let's see here. What do we need to do? We need another variable to check the LED state. So I'm going to come up here, and I'm just going to make an integer. And we're going to set that to 0. Right now, we're just going to assume it's off. And then, this is the same. We don't need to change anything here. And then we get into the loop. Let's see, button state. Can probably leave that there. And I want to add, we're going to use more if statements. And we're going to do a little bit of something called nesting. And we're going to nest these two if statements. So let's see, if button state curly bracket, if button state, and then if. Now I'll explain this in a minute. You got to be careful when nesting control statements because it can get pretty confusing. And a good thing about the Arduino IDE is it does show you where you're at. So it helps eliminate some of the confusion. So we're just going to indent that a little bit. And I'm going to say equals 0. You know what? I'm going to close that. Oop, come on. What are you doing? And then I'm going to say else LED state equals 1 semicolon. And let's make sure we got 2 if statements with 2 different loops. Okay. I think that is it. Now we did want a delay, so I'm just going to do half a second delay. That'll give us enough time to take our finger off of it. And I want to change this line of code right here. I'm going to change this to if LED state equals, well, 1 and higher, the same thing, but I'm just going to put the number 1. And then digital write high, right, else digital write low. I don't know that we need this delay here, so I'm just going to comment this out. So let's go ahead and check this and see, make sure I didn't make any mistakes, first of all. So I kind of did this on the fly. Okay, so it looks like it compiled, and you can't see it. I'm going to go ahead and upload it to the board. And while it's uploading, just for clarity, I want to have a little inset here, a picture of what we want to do. We want to press the button once, LED stays on, and then press it again, it goes off. And as we can see from the little inset, that is what we're going to be doing. Okay, everything looks good. So now let's step through this again. Now these 3 integers and variables, which are integers, they didn't change at all. We just added a new variable, another integer, LED state. And you'll see why we need that in a minute. This stuff stays the same. No need to worry about that. And this one stays the same too. Now here, this is just saying, look, if button state is true or 1, then fall into this other if statement. So if LED state is true, so if LED state is set or 1, well, we got to turn it off. So we fall into this here, and we turn it off by making it 0. So if button state is a 1, if it's pressed, then we come over here, we check the state of the LED. And if it is on, we turn it off. If it's not on, then we turn it on with this else statement here. And then we have this little delay that gives us time to take our finger off of the button. And now here again, we have, okay, so if LED state equals 1, we write a high to the pin 11 and we turn it on. Or if not, we write a low to pin 11, turn it off. So the only tricky part about this code here, again, is just when you get into nesting if statements and nesting loops, it can be a little bit confusing to see how the logic flows. But again, we'll go through it one more time just to make sure you guys understand. So we fall into this if statement here, and if button state is true or 1, okay, because if it's not true, we skip this part, and then we make it true. And then we turn it on. Okay, but if it's true and on, or set to 1, we fall into this other if statement. And then we check the state of the LED. And it's either going to be 0, 1, off, or on. If it's on, it's going to be 1. Then we're going to toggle it to off and set it to 0. And that's really all it does. So there's a lot of other things we can do with buttons. And in our next lesson, we're going to actually add more buttons and do some more things. But for now, guys, go out there, give this a try. See if you can, write code like this. First, try it without peeking, and then see if you can't get it right. Come back, check, see, what your mistake is if you made any, and then see if you can alter it too. I mean, maybe you can have it, go off after a certain amount of time after pressing the button. Anyway, I will see you guys in the next lesson. If you're interested in Arduino and microcontrollers, you'll love how to get started with Arduino in 1 day or less. Get instant access now by clicking the link below in the description.